In this lesson, we're going to look at graphing the tangent and cotangent functions. So we're going to start first with looking at the unit circle, and let's remember how to calculate the tangent function. So we know to calculate tangent, we have to take the sine of the same angle and divide it by the cosine of that angle. Now, sine and cosine on the unit circle, we're going to use the coordinates of the points, and sine is just the y value and cosine is the x value. So I'm going to go ahead and label this unit circle with the tangent values for each of our special angles. So tangent of 0, for example, 0 degrees or 0 radians, is 0/1, which would just give us 0. Tangent of pi fourths would be square root of 2 over square root of 2, which would just give us 1. And those two are some of the easier tangent values to calculate, but tangent of 30 degrees or pi 6 would be 1 over square root of 3, or square root of 3 over square root of 3 over 3. And then tangent of 60 degrees or pi thirds would just be square root of 3 over 1, which is just square root of 3. And then tangent of pi halves, or 90 degrees, would just be 1 over 0. We cannot divide by 0, so the value for tangent at pi halves would be undefined or does not exist. Now I'm going to label the rest of the unit circle with the tangent values. Now, if you look at the unit circle, you'll notice that we have undefined values at pi halves as well as 3 pi halves, or 90 degrees and 270 degrees. What our graph will have there are asymptotes, because our tangent graph will keep getting closer and closer to those x values without ever crossing those x values. So that means that for my graph to be graphed in its entirety for the tangent function, I have to take all of the x values from 0 to 90 degrees or pi halves, and then from 0 to 3 pi halves. But notice I'm rotating negatively, so I'm going to do from 0 to negative pi halves. And that will be the domain or x values that I consider for my angle. Now, when I'm going to make this table, I'm only going to write down the tangent values that are really pretty and easy to graph. So I'm going to put 0 degrees in the middle, and then pi fourths or 45 degrees and 90 degrees. And then towards the negative side, I'm going to do negative 45 degrees and negative 90 degrees. And the reason, again, I'm rotating negative is because I need my graph to be between these two undefined values. And for it to be a continuous graph, I need to just start at 0 and go negatively and positively. So now I'm going to write the tangent values for each of those angles. Now that we have written this table, let's go ahead and plot these values on our graph paper. So I labeled my angle measurements, or the measurements for theta, on the x-axis, and the y-axis I just have it labeled from -5 to 5. And now I'm going to plot all these values we have discovered. We know at negative 90 degrees and 90 degrees we have asymptotes, because the functions do not exist. The tangent function does not exist at those values. So now that I've drawn my vertical asymptotes, I'm going to label the 3 points that I have. At negative 45 degrees, it's -1, 0, 0, and 45 degrees, 1. And I know my graph keeps getting closer to the asymptote without crossing it. So this is what my tangent function should look like. If I go past the asymptotes and start labeling 3 pi fourths, which is just -1, and pi, it's just going to start repeating itself in the same manner. So that helps us know that my one period of my tangent function is equal to this width, which is equal to pi, right? Because negative pi halves to the left, pi halves to the right. My period is pi for a tangent function. And my amplitude tells me how tall my graph is, but since it doesn't have a minimum or a maximum, there's no actual amplitude for a tangent function. Now for the domain and the range, the graph keeps going infinitely down and up, so our range is all real numbers, and our domain is all real numbers except for the asymptotes. So all of our x values or theta angle values can be all but all the multiples of 90 or pi halves. And the reason is every single time we rotate to 90 or negative 90 degrees, we're just going to get another asymptote. Now let's consider the graph of the cotangent function. Remember, we calculate cotangent by doing cosine of theta divided by sine of the theta, which from the coordinates of the points on the unit circle are just x divided by y. Now, given what we know, the cotangent and tangent are reciprocals, I know that the angles that will give me the nice values to graph are these. And all of the pi fourths, 3 pi fourths will still have the same values. However, when I go to my degrees being 0 degrees or 0 radians for my angle, I would need to do 1 divided by 0, which makes my cotangent value undefined at 0 degrees. And the other place where I divide by 0 is negative 1 divided by 0 at pi or 180 degrees. So both of these are undefined. And then at pi halves, when I do 0 divided by 1, I just get 0 for my cotangent, and same thing with 3 pi halves, my cotangent value is 0. And that makes things easy to see from where to where I need to consider my cotangent values, because quadrant 2 and 3 just repeat what quadrant 1 and 2 are. So I just need to rotate from 0 to 180 degrees or from 0 to pi to get my full period for my cotangent graph. So let's go ahead and write out our table for these values. And again, the reason I do not need to write the rest of the points that are on this unit circle is because once I go from 180 degrees to 225 degrees, I just start repeating. So I go 1, 0, 1, undefined again. This should be negative 1. So 1, 0, negative 1, undefined. So it just starts repeating the same graph. So now that we have our table, let's go ahead and graph this cotangent function. So same as before, when my function is undefined, I just have vertical asymptotes at 0 and at 180 degrees or pi. And then at 90 degrees, my y value is 0. At 45 degrees, it is 1. And at 135 degrees, it is negative 1. And for my cotangent, same thing. I start close to the asymptotes without crossing them, and then I go through the 3 points. And the graph keeps going up and down as it gets closer and closer to the asymptotes. And if I was to graph the rest of the points from the unit circle, if I was going to go in the negative side, the graph would start repeating. So as you can see, just as before, our period for the cotangent function goes from 0 to pi or 180. So our period is equal to 180 degrees or pi. And our amplitude does not exist because our graph keeps going up and down. There's no stopping it, so there's not a special type of height that we have. The range is again all real numbers because our graph keeps going up and down. And the domain is all real numbers except our asymptotes. So here's a quick summary of what tangent and cotangent graph functions look like and their domain, range, period, and amplitude. So make sure you are ready to use these notes for our next practice.